Good afternoon, dear children. Let me continue the lesson. See, in our last class we have started the physical properties of metals and non-metals, and the two important properties we have discussed. Now, the first property was the physical state. Now, so what was the physical state of metal? The physical state of metal is always hard. Now, they are very strong, but except mercury, because mercury will get in liquid form. In the case of non-metals exist on Earth as solid, liquid and gas both. Okay, all. Next, if we come to the lustrous part, the second physical property, metals have shiny appearance. Luster means, I told you yesterday, metals which forms the shyness in them. If they have the shyness, then they are called as a metal. But example or exception, the lead. Lead is a metal, but the lead appears dull. Non-metals, if we see, all the non-metals are non-lustrous. They do not shine. Except diamond. Diamond is a non-metal, but it shines because of the refractive index. Okay, so in physics you have learned about the refractive index, which gives the shyness to the object. So diamond have the capacity to shine because of refractive index. So let me move on to the third property, the third physical property of metals and non-metals. That metals are malleable. They are malleable or malleability. What do you mean by malleable? Malleable is a process. Okay, so it is a process where if you beat or hit with the hammer to the metal, you can form the thin sheets. So those metal by applying pressure, if it makes or if we get the sheets, thin sheets, that process we call it as a malleability. Okay, it's a malleability. For example, see, example called aluminium, okay, copper, like this tungsten wire or tungsten, this we get as wire. But aluminium and copper, for example, aluminium foil we will get. Now, food, for the food they wrap. So, if we buy the food from outside hotels and all, they will pack it. So, what they use while they packing? They use the aluminium sheets or aluminium wrappers. So, the food what we purchase, they wrap with the aluminium sheets. So, that much thin we can make these metal. Okay. Next, copper. See, if we see the chocolates and all, so there will be a brown color wrapper it covers. Now, so the chocolate was covered by the wrappers. That wrappers was a copper wire, means copper sheets. Okay, it is made up of a copper sheets. So like that much thin. Then one more very malleable metal is a gold. Au, gold. We use for the jewelry purposes. Okay, see children, about 1 gram of gold we can make 2 kilometers of wire in it. Okay, so see that we can make this silver, okay, gold and all as a thin sheets. So we can make it to the any kind of shapes. Understood? So what do you mean by the malleability? If we get there is a thin sheets, they are called malleable. But non-metals are non-malleable. They are the non-malleable. Why? Because breaks. Because the metals, if you want to hit with the hammer, the non-metals breaks. For example, let's take chalk. If we beat or if we hit to the chalks, what we'll get? We'll get the pieces of chalks. So that's why non-metals are non-malleable. The next important property is the ductility. Ductility. What do you mean by ductility? Ductility means we can make the metals into thin wires. Thin wires. For example, aluminium wire, copper wire, again gold wire, silver wire. Okay, if we are making into the thin wires, that process we call it as a ductility. But if you come to the non-metals, they are non-ductile. You cannot make it as wire. Okay, so those elements which we make as a wire, okay, whether it may be thick or thin, we call that process as a ductility. If both, they are the non-ductile. Understood? Yeah. So let me move on to the next physical properties. That is atomicity. Atomicity. What do you mean by atomicity? See, the name itself tells that how many or how the arrangement of atoms takes place in metals and non-metals. See, in the beginning of my lesson only I have explained you that each and every element is made up of atoms. Now, we know that. So, the elements, those elements, the arrangement of elements with the help of atoms, because if the atoms arranged it, if it is very hard and strongly arranged, so we call it as a solids. Now, if they are freely arranged, loosely arranged liquid, freely arranged gases. Okay, so likewise, all the metals, their atomicity will be monoatomic. Means one kind of atom will takes place. Okay, so this gives the hardness or rigid to the metals. Understood, children? See, for example, sodium, magnesium, calcium, okay, etc. They are all the monoatomic because there is no 2 number, 3 number, 4 number, no. There are no numbers are there. Only the element or the metal which forms with a monoatomic. Mono means one. Okay, mono means one, single. So those elements forms with single atom, they are called monoatomic. So the atomicity of the metal is monoatomic. In the case of non-metals, some non-metals made with diatomic, some are triatomic and some are polyatomic. Okay, for example, I2, Cl2, okay, O2, Br2, etc. Means those those non-metal made with 2 atoms, they are called diatomic non-metals. Understood? Or diatomic elements. For example, I2, Cl2, O2, Br2, all these are. So next, O3. What is O3? Ozone. What is the number of atoms present in the ozone? It is 3. If the number of atoms present 2 number of atoms present for the O, that we call as a oxygen. But O3 we call it as a ozone. Understood? Because 3 atoms, it is made up of 3 atoms. Next, polyatomic, maybe P5. Okay, so CaCl2. Understand? So, like this, many substances you will find, or the elements you will find, which made with the many numbers, either 2 or 3 or 5 or many numbers. Okay, so they are called as a for the non-metals, diatomic, triatomic, polyatomic, they are called as atomicity. Okay, so let me revise once again. Those elements which having or which form with the one atom, they are called monoatomic. So atomicity of metal is 1, monoatomic. So non-metals, diatomic, triatomic and polyatomic. Understood? The examples are like this. Metals are good conductors of heat and electricity. Good conductors of heat and electricity. Here they are the bad conductors. They are the bad conductors of heat and electricity. See, the next important property is good conductors. All the metals are okay. So they conduct electricity. Why they conduct electricity? What is the reason? Because they are having a mobile electrons. Because of mobility or mobile electrons. Mobile means not the gadget which we use. Mobile means the free movement of electrons takes place in that element. Understood? So, electrons, if there is a free moving of electrons will be there, they can conduct the electricity because of free movement of electrons. But if in the case of non-metals, no free moving of electrons, no mobility. Understood, children? So, they do not conduct the electricity. For example, see, all the metals conduct electricity. The example mercury. Okay, so like this, some metals are there which do not conduct the electricity. But here in the case of non-metals do not conduct electricity except graphite. See, graphite is a non-metal but it conducts electricity. Why it conducts electricity? What is the reason? In the next lesson, carbon and its compounds, I will explain in detail. Understood? Yeah. So this is one of the important property. Next, metals have high melting and boiling point. See, to show certain extent or the certain range of the values, okay, elements, if you melt the elements, it shows, if you keep the thermometer, it shows the some reading. Okay, so if you boil the solution, it shows some reading. Compared to non-metals, metals have high melting and boiling point. Understood? But except mercury. Mercury is a low. Okay, so mercury have low melting and boiling point. Understood? Next, so non-metals have low melting and boiling point. It shows low melting and boiling point. Except oxygen, carbon, sulfur, like this. Okay, so silicon. Okay, so they are the high melting point. So, but the metals have low melting point, non-metals have high melting point, non-metals have low melting point. Understood, children? So, I hope you have understood some of the important physical properties. Okay, go through the textbook, read every day the lesson. Whatever the concepts we are completing that particular day, you have to read the lesson of it. Then you go for class.